This is SpaceTime, Series 22, Episode 16. Coming up on SpaceTime. New data shows asteroid impacts on Earth have been increasing. A new study of gravitational waves, which could help settle debate over cosmic expansion and the ultimate fate of the universe. And one of Britain's black arrows returns home. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims Earth has seen an increase in asteroid impacts over the past 290 million years. The findings, reported in the journal Science, are based on new dating techniques being used to determine the age of impact craters on the Moon. Scientists using images and thermal data collected by NASA's Lunar Reconnaissance Orbiter spacecraft have calculated the age of large lunar impact craters across the Moon less than 1 billion years old. By comparing the impact history of the Moon with the Earth's craters over this interval, the authors discovered that the rate of sizable asteroid collisions has increased by a factor of 2 to 3 on both bodies over the past 290 million years. For decades, scientists have tried to understand the rate at which asteroids hit the Earth by carefully studying asteroid impact craters on the Moon and by using radiometric dating of rocks around them. The problem is, Earth has far fewer older craters than expected compared to other bodies in the solar system, making it difficult to find an accurate impact rate and determine whether it's changed over time. Scientists always assumed that the earliest impact craters on Earth have been eroded away by wind, water, and geological processes, mechanisms not present on the Moon. But one of this study's authors, William Bottke from the Southwest Research Institute in San Antonio, Texas, says his research indicates the Earth has fewer older craters on stable terrains not because of erosion, but because the impact rates were actually lower prior to about 290 million years ago. Though large impact craters are rare, the Earth and the Moon are hit at roughly the same proportions over time. Lunar craters experience little erosion over billions of years. But scientists couldn't pinpoint their ages until NASA's Lunar Reconnaissance Orbiter started circling the Moon a decade ago, studying its surface. The spacecraft's thermal radiometer, called Diviner, measures the heat radiating off the Moon's surface. By looking at these data during the lunar night, scientists were able to measure how much of the surface is covered by large warm rocks, as opposed to cooler, fine-grained lunar soils. Large impact craters formed in the last billion years or so are littered with boulders and rocks, while older craters are far smoother. Using a relatively new technique designed to calculate how long it takes to reduce lunar rocks to soil, the authors were able to calculate the age of lunar craters younger than about 1 billion years. They found that the rate of large crater formation on the Moon was about 2 to 3 times higher over the last 290 million years compared to the previous 700 million years. The reason for this increase in impact rate is unknown. It could be related to large collisions taking place more than 300 million years ago in the main asteroid belt between the orbits of Mars and Jupiter. Such events can create debris streams that ultimately reach the inner planets and the Earth-Moon system. The authors were also surprised when they compared the ages of large craters on the Moon to those on Earth. Their similar size and age distributions challenged the theory that Earth had lost many of its craters through erosion on stable terrains back to about 650 million years ago. The authors were able to confirm their deduction by studying kimberlite pipes, long extinct volcanoes stretching in a carrot shape several kilometers below the surface. Scientists know a lot about the ages and rates of erosion of kimberlite pipes because they're widely mined for diamonds. They're also located on some of the least eroded regions on Earth, the same places where we find preserved impact craters. Scientists found that kimberlite pipes, which formed about 650 million years ago on stable terrains, had not experienced much erosion, indicating that large impact craters younger than this in the same regions should also be intact. The findings also have implications for the history of life on Earth, which is punctuated by extinction events, followed by the rapid evolution of new species. You're listening to SpaceTime. I'm Stuart Gary. Scientists speculate that measurements of gravitational waves from around 50 binary neutron stars over the next decade will ultimately resolve the intense debate about how quickly the universe is expanding. The cosmos has been expanding out ever since the Big Bang 13.8 billion years ago. Its present rate of expansion, known as the Hubble Constant, gives the time elapsed since the Big Bang. The problem is the two best methods used to measure the Hubble Constant have conflicting results, and that all suggests that science's understanding of the structure and history of the universe, known as the Standard Model of Cosmology, may be incorrect. Now, a report in the journal Physical Review Letters shows how new independent data using gravitational waves emitted by binary neutron stars could once and for all break the deadlock between these conflicting measurements. The study's lead author, Dr. Stephen Feeney from the Flatiron Institute in New York City, says calculations indicate that by observing 50 binary neutron stars over the next decade, astronomers will have sufficient gravitational wave data to independently determine the best measurement for the Hubble Constant. The Hubble Constant, which was developed through the work of Edwin Hubble and George Lemaitre back in the 1920s, is one of the most important numbers in cosmology. The constant measures the expansion of the universe out from the Big Bang to the present day. It's essential for estimating the curvature of space-time, therefore the edge of the universe, and for exploring the cosmos's ultimate fate. Astronomers measure the Hubble Constant using two methods. The first observes Cepheid variable stars and Type 1a supernovae in the local universe, measured by the Hubble Space Telescope and the Gaia Telescope. These give a reading of an expansion rate of approximately 73.5 km per second per megaparsec. A megaparsec being a million parsecs, or about 3.3 million light-years. Cepheid variables are unusual stars which pulsate, in other words expand and contract, at set rates based on their intrinsic luminosity, and this can be used as standard candles to measure cosmic distances. You see, because astronomers know how intrinsically luminous a Cepheid variable is because of its pulsation rate, they can determine how far away that star is, in exactly the same way as a row of streetlights all of the same brightness, but the ones further down the road will appear dimmer than the ones nearest to you. In physics, it's called the inverse square law. And the same goes for exploding stars called Type 1a supernovae. These stars all explode at about the same mass, and so roughly with the same amount of brightness. And so, like Cepheid variables, they can be used to determine cosmic distances through the inverse square law. Now, the second method for determining the Hubble constant uses measurements of the cosmic microwave background radiation. In simple terms, the cosmic microwave background is the leftover heat from the Big Bang, now just 2.7 degrees above absolute zero. It was released when the cosmos cooled enough for the first atoms to form and photons to escape, about 380,000 years after the Big Bang, which, according to measurements by the Planck spacecraft, is 67 km per second per megaparsec, significantly slower than the Hubble Gaia measurements. Having two different numbers for the Hubble constant means science's understanding of cosmology is obviously missing something. So, to try and resolve the issue, the authors have set about trying to develop a third method to calculate the Hubble constant, coming up with a universally applicable technique using gravitational wave data. A gravitational wave is generated by a moving mass, such as merging neutron stars or black holes. As it passes through the cosmos, the gravitational wave causes the very fabric of space-time to stretch and compress ever so slightly. It's just a fraction of the diameter of a proton. But now, thanks to gravitational wave observatories like LIGO and Virgo, scientists can detect it. Gravitational waves emitted when binary neutron stars spiral towards each other before colliding also emit a flash of bright light, which can be detected by telescopes. While binary neutron stars are rare, they'll be invaluable for providing another route to track how the universe is expanding. The gravitational waves they emit will ripple across space-time. They'll be detected by the laser interferometer gravitational wave observatories LIGO and Virgo, giving a precise measurement of the system's distance from Earth. And by also detecting the light from the accompanying explosion using electromagnetic telescopes, astronomers will be able to determine the system's velocity, and hence calculate the Hubble constant using Hubble's law. For this study, the authors modelled how many such observations would be needed to resolve the issue, ultimately coming up with a figure of 50 such observations. And this in turn will lead to the most accurate picture of how the universe is expanding and how it will ultimately end. I'm Stuart Gary. This is SpaceTime. After almost 50 years in the Australian outback, the only British rocket to successfully launch a satellite into orbit has been returned home. The remains of the first stage of the Black Arrow were brought back to the UK as a symbolic gesture for educational outreach by the Edinburgh-based rocket developer Skyroarer. The company successfully completed an inaugural suborbital test flight from Scotland last year, and it's about to start testing a new upper stage orbital engine in Cornwall. The work's all part of a UK Space Agency plan to develop a vertical orbital launch complex at Sutherland. Black Arrow was a 3-stage launch vehicle developed in the 1960s and based on the earlier Black Knight rocket. Its first stage was powered by an 8-chambered rocket motor called a Gamma 8, which was fueled by RP-1 kerosene and high-test hydrogen peroxide. A smaller 2-chambered version called the Gamma 2 was used for the second stage, while a single solid rocket motor was used for the third stage. Only 5 Black Arrows were ever built, with only 4 actually being launched, all from the Woomera rocket range in outback South Australia. The first launch in June 1969 was a suborbital test flight of the first 2 stages. However, the mission ended when the rocket's thrust vectoring system failed. The second launch in March 1970 was a successful suborbital test mission of the first and second stages. The third launch in September 1970 was intended to place the UK's first satellite, the Obra X2, into orbit. The mission, however, failed to reach orbit after the second stage shut down 13 seconds early. Obra was built using spare parts due to funding restrictions, and was to have been used to measure upper atmosphere density by monitoring the decay of its orbit. The Black Arrow's fourth and final launch from Woomera in October 1971 was successful, carrying the Prospero X3 satellite into orbit. Prospero was designed to undertake a series of experiments to study the effects of the space environment on communications satellites, and it remained operational until 1973. The Black Arrow project was then suddenly retired after only the 4 launches in favour of using cheaper American Scout rockets. The 5th Black Arrow built was then placed on public display at the Science Museum in London, although a replica is on display at Rocket Park in Woomera. To find out more, Andrew Dunkley is speaking with astronomer Fred Watson.
The Black Arrow projectile. This is a really interesting little yarn.
Indeed, it is. It was more than a projectile. It was actually a launch vehicle. This was Britain's launch vehicle, developed during the 1960s. I remember when I was a lad, when I was leaving university and actually, thinking what I'd like to do with my career, because I absolutely wanted to be an astronomer, but there were other avenues that looked as though they might be related to that. And one of them was working for the company that was developing the Black Arrow, called Cassidy Dynamics. So when I was graduating from university and thinking about these things, it was very much on my horizon. Indeed, the Black Arrow project flourished between 1969 and 1971, of which the third flight was the first and actually only successful British orbital launch. I think it was Britain and a number of other countries as well, but Britain took the lead on that. So they actually put a satellite into orbit using the Black Arrow launch vehicle. And this really was the highlight of the Black Arrow program, because after that it was cancelled, presumably because of the sheer expense that's involved in developing these things. And by then there were competitors well established across the Atlantic from the United Kingdom. But that short life has given it, the Black Arrow rocket, a kind of almost legendary status. And I kind of feel that as well because of my nearly getting involved with it when I was just leaving uni. So where did it make its flight? Well, it was here in Australia. Even though the Black Arrow was built in the UK, it was launched from the Woomera launch facility in South Australia and basically put its satellite into orbit and then fell back to Earth and landed in the South Australian desert and has been there ever since until now, because this story is a rather nice sort of heritage type story involving I was going to say remnants. I think it's mostly in one piece, but it's very, very bent. Its various components have been seriously rearranged, the Black Arrow launch vehicle, but it has been brought back from Australia into the United Kingdom. And in fact, it is actually going, curiously, to a small town in Scotland where I used to live, a wee place by the name of Pennycook, not very far from Edinburgh. I lived in Pennycook for quite a number of years during the 1970s and 80s. So it's very nice to think that this piece of space history is going to be put on display, actually, in Pennycook.
All right. Now, the obvious question is why? is it going to Pennycook?
Yes, I'm very, very glad you asked me that, Andrew.
I'm sure you would have told me without asking, but I need to feel useful.
It's because the company that's paid to bring it back actually is a high-tech company based in Pennycook. Its name is Skyrora. I think they do basically space-based industry, and so it's fantastic that this rocket vehicle is coming back there. The other really interesting aspect of this, though, is that Scotland might, in a few years, have its own launching site, bearing in mind that in the 1960s and 70s, British rockets had to be launched from Australia. Things have changed to the extent now that in far northern Scotland, you could actually have a viable launch site, particularly for north-south launches. That's to say, spacecraft going into what we call polar orbits. You tend to need a fairly clear eastern horizon, if I can put it that way, preferably with ocean there for normal satellite launches. And you tend to want to be near the equator. Now, Scotland is not near the equator, but far northern Scotland will be a perfect location for polar launches, to put launches over the pole. And that is the usual kind of orbit that many military spacecraft are in, and also a lot of communication spacecraft too, such as the Iridium ones.
If they're going to start launching rockets from Scotland, they're going to have to really improve on their caber tossing, because seriously, that ain't going to do it.
Well, that's probably who they'll get to do it. Always, hey, we can throw a beam of wood, so we can launch a rocket.
Yeah. Maybe. It actually reminds me, and I'm glad they found it, and I'm glad they decided not to leave it in the middle of the desert rotting away and letting the vandals get to it, because I know they had a couple of cracks at it. But it reminds me of Australia's first attempt at a launch vehicle, which turned out to be a leftover American rocket.
It was, that's right.
Which we painted over with a kangaroo, and we launched it. And it came back down to Earth, and the paint half burnt off and revealed the American flag or the letters USA or something. And they shoved it in a chook pen, and it's still there to this day.
What else do you do with one of these?
We're so classy in this country.
It launched, if I remember rightly, was it RESAT? WRESAT?
Something like that, yeah.
Yep. Yep, Weapons Research Establishment satellite. Yeah, very interesting stuff. Well, there you go. So what delights me, Andrew, about this is that the space age has its own history, and I've seen most of it as well. I certainly remember the first
I didn't mean to laugh, Fred.
No, it's true. And it's great to be able to see at first hand this progression of the technology from these first attempts like the Black Arrow and things of that sort to what we see now with SpaceX sending launch vehicles back up and landing them back on Earth on their tails and things of that sort. It's brilliant stuff.
At least the English one had a good name.
It's about all it had.
Yeah. But it is fascinating history, and I'm glad it's found a new home. It certainly beats being put in a chain mesh fence enclosure.
With chooks.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. And time now for another brief look at some of the other stories making news in science this week with a science report. A new study claims regular use of anti-inflammatory drugs such as aspirin or ibuprofen could help patients with head and neck cancers. Scientists found that regular use of these drugs lowered levels of inflammatory molecules found in patients with head and neck cancers, helping to improve survival and recovery. You can read the findings in detail in the Journal of Experimental Medicine. Scientists are warning that the last coastal stronghold of the highly endangered Bengal tiger could be destroyed by climate change and rising sea levels within the next 50 years. There are now fewer than 4,000 Bengal tigers alive today, mostly due to habitat loss and poaching for Chinese medicines that don't work anyway. The few remaining members of the world's largest cat species, now mainly confined to small areas of India and Bangladesh around the Sundarbans region. A new study by scientists at James Cook University has found that tiger habitats in the Sundarbans will vanish entirely by 2070 due to a combination of land loss from human encroachment and development and climate change. A new study has concluded that last September's major earthquake near Palu City on the Indonesian island of Sulawesi was what's known as a rare super shear event. Fewer than 15 of these fast-moving, extra-powerful earthquakes have ever been identified. In these events, the rupture or propagating crack moves along a fault extremely rapidly, causing the up and down or side-to-side waves that shake the ground, known as seismic shear waves, to pile up and intensify. The result is a much stronger and more violent shaking than a regular slower earthquake. Researchers with the University of California, Los Angeles, and NASA's Jet Propulsion Laboratory in Pasadena, California, together with other institutions, analysed high spatial resolution observations of the seismic waves caused by the earthquake. They also examined satellite radar and optical images to characterise the speed, timing and extent of the magnitude 7.5 event. They've calculated that this quake ruptured at a steady speed of 14,760 kilometres an hour. Now that compares to regular earthquakes, which typically rupture at between 9,000 and 10,800 kilometres per hour. The researchers also found that the two sides of the 150 kilometre long fault had slipped by about 5 metres. Optus says it'll have fixed 5G broadband services available for more than 1,200 5G sites around Australia by March 2020. The company says the service is already live at 2 sites in Canberra and will be available from another 47 next month. Optus expects other 5G sites to be live in Adelaide, Brisbane, Perth and Sydney over the coming months. It says the initial 1,200 sites include both residential and hotspots surrounding airports, train stations, sporting stadiums and central business district locations. A new study claims that animal life's evolutionary Big Bang, otherwise known as the Cambrian explosion, ended much sooner than previously thought. A report in the Journal of the Proceedings of the National Academy of Sciences has found that the Cambrian explosion was over within 20 million years of the start of the Cambrian period 541 million years ago. The Cambrian marked a profound change for life on Earth. Although the Ediacaran, when complex life forms evolved, had already begun, on the whole, prior to the Cambrian, the majority of living organisms were small, unicellular, and simple. However, the Cambrian explosion saw a sudden and major change in animal diversity and complexity, with the variety of life beginning to resemble that of today. Almost all present animal phyla appeared during this period. The study's lead author, Professor John Patterson from the University of New England, says the Cambrian explosion was shorter and sharper than anyone had imagined. Well, it seems spending time in space is changing the makeup of astronauts' brains. The findings, reported in the Journal of the American Medical Association, investigated the free water and white matter content of the brains of 15 astronauts after missions of varying lengths. As well as an unusual upward shift of the brain within the skull, scientists found an increase in free water and changes to the white matter near the top of the brain. These changes were most common in astronauts who spent extended periods in space, or those who were involved in more than one space mission. The other day a friend told me he saw a warning on Facebook that you should never give your pets chilled water on a hot day because it's bad for them and could even kill them. I was a bit sceptical of it, so I checked it out. It took me just 2 minutes online to get the real facts and confirm this story was a load of trash. Veterinarians all say it's fine to give Fluffy or Fido chilled water on a hot day. But this incident supports an old saying that a lie can travel halfway around the world before the truth gets its boots on. And so it is with fake news. From anti-vaxxers to climate change deniers and flat earthers, the problems of fake news have always been there. But thanks to the internet and social media, it seems to be a bigger problem now than ever before. So, how can you tell what fake news is? Well, when looking at any story, you should always consider the source. Click away from the story to investigate the site, its mission, and its contact information. Check out the author, make sure they're creditable and that they're real. And read beyond the headlines, because often the headlines are simply designed as clickbait to get more hits. And always check out supporting sources. Click on the links to see if the information given actually supports the story being told. Also, and this might sound obvious, but even I've been caught on this one, don't forget to check the date. Make sure the information is still relevant to current events. Another important thing to double check is make sure the story isn't meant as a joke. It could be satire. See, sometimes the authors aren't very good at telling jokes, or more likely they're simply not bright enough to clarify what they're doing. And finally, and this is what I tell everyone, always do your own research. See what various other experts on the same subject say, and always go to credible sources, and no, that does not mean the ABC or other news websites. Remember, journalists can be fooled just as easily as everyone else. Plus, they've got their own biases and opinions, which, no matter what they say, does affect the way they write up a story, both in what they put in the story and what they leave out of it. And all that happens before the sub-editors get their hands on the story and make their own changes. If it's a scientific claim, it's easy to check up. Always go to a peer-reviewed scientific publication and see what they've said on the same subject. The current issue of The Skeptic has tackled the growing problem of fake news. But Tim Mendham from Australian Skeptics warns there's now so much fake news around, fact-checkers are being overwhelmed by the sheer volume.
This is an ongoing problem, of course, is that there's many more cases of people putting forward claims than there are people debunking them, or at least investigating them and finding out if there's any value behind them. One of the areas, a lot of medical areas. I mean, obviously, you go online, the Dr. Google approach, there's so much information out there, information in quotes, which is total BS. Right? There's no substantiation for it at all. There's no scientific backing for it. There's no medical backing for it. It is just sort of made up stuff, and it sounds impressive because it's all wrapped up in nice colours and things like that. The classic stuff is the Gwyneth Paltrow goop information. Now, the trouble is trying to find people who will actually spend the time going behind all these claims is very difficult because the old story is it takes 1 second to start a bushfire, it takes 3 weeks to put it out. And that's the proportion you see of someone who's making a silly claim and someone who's trying to sort of counter it. There are a number of groups doing that, but honestly, they have a hard work and they're working uphill. In that article you mentioned in the magazine, we looked at a number of places that are doing that, and one of them is just closing down because, quite frankly, it's just so hard and it's just so costly to do, to put out those bushfires. And as soon as you put one out, another one starts, another one starts, another one starts. So, unfortunately, countering the fake news is a lot harder than creating fake news.
That's Tim Mendham from Australian Skeptics. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.